So our first objective after reviewing our pre-calculus was to be able to find limits graphically. So we'll just go through the examples that were in the notes. We already have examples from the quizzes that I will put after this in the playlist, so if you want to go through those, you can. So first question here gives us a graph. You can see this graph doesn't appear to be continuous, right? We could even say it's a jump discontinuity. But as we approach, right, let's break down what we see here. This one we see at the bottom, X arrow 0 with a little negative sign. So a little negative sign is what's telling us, in fact, let me erase this so I have less of it. The little negative sign is what's telling me that we are doing this from the left, right? We know what we're approaching because that's the value here, so we can just go ahead and put that into this little fill in the blanks. But this is really connecting the words to that function, to that limit notation that we've gotten pretty good at already. So if we're approaching 0 from the left-hand side, that means we're going to come from this side towards 0. Really wanted that to be pink. How can we do it? So we're kind of doing that. You can imagine going back to this activity. This is approaching from the left. We are approaching the value here at 1. So we could write that here, and then we could finish our function notation. Great. If we go from the right-hand side, so from the right, from the positive values, if you're thinking about the number line, right, then we are approaching instead the actual point that occurs at 3. So, and we're still talking about 0, because that's what we're headed to. So we could add our little, the plus sign is what's telling what we're going to. The value itself is telling me where we're going on the graph towards the 0. And then we can see exactly where the function is sort of hitting. All right, and now here's the next piece, that two-sided limit. In order for us to have a limit as x goes to 0, these two things have to be in agreement. If they are not, this does not exist. And this is where we get to use that language, does not exist. And it is perfectly okay if you want to write D and E. That is an accepted shorthand for does not exist. And so if we were trying to write what this is, again, we're still approaching 0, but now we're talking about from both sides because there's no plus or minus. Cool, so that doesn't exist. Now, f of 0, this is asking what the actual value of our function is at x is equal to 0. And this is where we're looking for a closed circle. And we had one on our graph. So in this case, on our graph, we did have that closed circle up at 0, 3. That was an actual value on our graph. So this is 3. The y value when x is still 0 is 3. So back to our function notation. All right, let's do a couple more. I won't break this up. I think we only have one more, I hope. And so we got another graph here. Oh, same graph, but now we're asking about the limit as x goes to 2 from the negative side. So that's from the left. Come on. I don't know why I decide sometimes I want to move the PDF and sometimes I want to write on the PDF. All right, so the negative side says left. We've changed our value now. We are talking about going towards 2. So let's put ourselves a little line over at 2. So 2. I think we've stopped switching 2. I'm going to type something. All right. Let us hope for my sanity this continues to work. So we are approaching 2 now. So we're going towards x is equal to 2, and we can do so from the right or the left. All right, and as we come in from the left-hand side towards that value of 2, we are approaching 5. And as we do that from the right-hand side, we're also going to be approaching 5. So I will not make you watch that because I think we're good here. And now since those two things are in agreement, our limit as x approaches 2, our two-sided limit as we approach from both sides is also 5. And then here's where we get the difference between our does not exist and our undefined. So f of 2, it's not that it doesn't exist, it's that we haven't defined it yet. Like the limit we know doesn't exist. We can see the left and right don't match. But for the function value, we don't know, it's just undefined. So we here, instead of writing does not exist, we write undefined. Cool. So when we're at exactly 2, it is undefined. It might exist, we don't see it, it hasn't been defined for us. Whereas for the limits, we actually know. We can see they don't match, it doesn't exist. It's not that it isn't defined. All right, so there we go, graphical limits. We haven't, in this particular set of notes, tackled our limits at infinity, infinite limits that also have been on our quizzes. So again, check out those quizzes or keep watching because I'll go through the notes on those in a second.